So you can say a basket has, say, 4 oranges, it has 3 mangoes, and then it has 5 apples. Okay. So basket has 4 oranges, 3 mangoes, and 5 apples. And then now you say two fruits. So all these are fruits. So two fruits are selected. Two fruits are selected without replacement. Without replacement. So what is the probability? What is the probability that it is the probability that one one the fruits are the same. What is the probability that the fruits are the same? Then two, the second fruit is uh, an orange. Okay, so you can have that example. Basket has 4 oranges, 3 mangoes, 5 apples, and two fruits are selected without replacement. What is the probability that the fruits are the same? So if it is the first one is a mango, then the second one is also a mango. If the first one is an apple, the second one is also an apple. And then the second question is asking you, the second fruit is an orange. Okay. And you can have as many questions from this. Okay. So we can attempt to represent this information, in a tree diagram. Okay. So solution. So using now a tree diagram. So we said we have, so if it is the oranges, we can use a no. Okay. So there are three different fruits. So you have an orange, we have a mango, and you have an apple there. Okay. So now this will now be your first pick, or your first selection. To be your first selection or your first pick. Now, what you know about these fruits is that the total number of fruits that you have there. So you have 4, 3, 5. So the total in this case is the total number of fruits that you have there. There are how many? So if you add that, that is if you add 4 plus 3 plus 5, so 4 plus 3, that would be 7, plus 5, that would be 12. So you have 12 fruits there. Okay. And therefore, if you have 12 fruits, then what is the probability that you pick an orange? So you have 4 oranges out of the total number of fruits. So picking an orange, the first here will be 4 out of now the 12. So picking a mango, so you have only 3 mangoes. So the probability that you pick uh, a mango will now be 3 out of 12. Okay. The probability that you pick an orange, an apple will be you have 5 apples in that basket out of the total number of fruits. That is 12. Okay. And then you observe that if you add these probabilities here, okay, if you add those probabilities, then you are supposed to get 1. So if you add 4 over 12 plus 3 over 12 plus 5 over 12, then you are supposed to get 1. So that is now the first pick. The first pick. Now, if you go now to the second pick, so if the first pick was an orange, then what is the chance? Oh, sorry. So the second could be an orange, or it could be a mango, or it could be an apple, like that. And then now you ask yourself, what is the probability if you picked the first one as an orange and it is without replacement? So once you pick, you don't return the fruit that you picked. Okay, so now you'll be working with the remaining number of fruits. So you picked one orange, so you are only left now with 3 oranges. And then the total number of fruits remaining are now 11. But you have not picked any mango so far, you have not picked any apple so far. That is if you're following, since you're following now this route here. Okay, so if the first fruit is an orange, then probability of getting a mango from here will now be the 3 mangoes that you still are still remaining. Then now the total number of fruits are 11. Then the apples will be 5 out of now 11 fruits. But now if the first fruit if the first fruit is a mango here, now the probability that you're going to get either an orange, or you get another mango, or you get an apple here. So that is what we want to establish, what will be the probability. Okay, and so you can see that if you pick the first fruit as a mango, you have not picked any orange yet. So your oranges are still 4, but now since you picked one mango, your total number of fruits have reduced to 11. And since you picked one mango so far, then it means that you're only left with 2 out of 11 fruits. You have not picked any apple, so you have 5 out of 11. And you observe that, like I said in the first case, if you try to sum these probabilities for every section there, then the probability should add up to 1. So that is important to note. It should add up to 1. Now, we move. If the first fruit, if the first fruit is now an apple, then what is the probability that you either observe an orange, or you pick a mango, or you pick another apple there? Okay? And so you have, if you pick the first fruit as an apple, then it means you've not picked any orange. So if you're following this route, you've not picked any orange, and therefore your oranges still remain as 4, but then the total number of fruits have reduced since you're doing this without replacement. And then you have not picked any mango. Again, if you're following this route, so your your mangoes are still 3, but since you picked one apple, the total fruits remaining in the basket are 11. Then if the first fruit was an apple, then it means that one apple is gone. So you have 4, then total number of fruits remaining are 11. Like that. Okay. And so now this one here is now the second selection. Okay. So the whole of this will denote, just use a different one. Okay. So the whole of this will denote the second selection. This here was the first. So first, okay. Then now this one here is the second. Okay, and that is why it is called a tree, because it looks like branches. You have branches spreading. And so if you observe now here, so you can have an orange and then an orange. You can have an orange and a mango. You can have an orange and an apple there. You can have a mango and an orange. You can have a mango, another mango there. You can have a mango and an apple. Okay. You can have an apple and an orange. You can have an apple and a mango. And you can have an apple and another apple. Okay. So now if we go back to our questions up there, okay. So what is the probability that the fruits are the same? So the same means that it could either be uh, an orange and an orange, or could be mango and another mango, or it could be an apple and another apple there. Okay, and therefore You can write this as, so probability, I think that is not clear. So probability, same type equals to, okay, and you can, I've allowed, you can now move your screen so that it is able to see the whole of that screen. So same type, so just move your screen, you can move it around and be able to see the whole of the whiteboard. So it will be the probability of observing an orange and an orange, or probability of observing mango and another mango, or probability of observing an apple and another apple, like that. Okay. And so whenever you use the term or in probability, we simply referring to addition. But when you use and, so like here we are saying it is orange and orange. So here we are looking for multiplication. Okay, and therefore you now come and check. So what is that probability of observing an orange and another orange? So it will be, so the first one will be 4 out of 12 multiplied by 3 out of 11, or, so or I've said it is add, then you have 3 out of 12 multiplied by 2 out of 11, like that, or you have 5 out of 12 multiplied by 4 out of 11. And then now you can try to simplify that. You can try to simplify that. So this one clearly, you can see that you can be able to cancel out 4, 1, 4, 3, and 3 by 3. So in the first one, you have 1 over 11 plus, so by 3, 1 by 3, 4, 4 by 2. So you have 1 out of 22 added 2. So by 4, 1 by 4, 3. So you have 5 out of 33. So you can just check whether that is correct, and then now you can simplify that. So what do you get? What is the answer for that? Now that you have your calculator with you. So you can write there on the chart. So Kelvin is saying 19 out of 66. Same case with the Teresia. Okay, so yes. Then now, thank you. So now we can check question two. If we just scroll question two, it is asking that the second fruit is an apple. I mean, it's an orange. Okay, the second fruit is an orange. Now here, so probability, second fruit, orange, will be. So now you check which root gives you an orange as a second fruit. Okay. Now, here, remember we are picking two fruits. Okay. So you can pick the first fruit as an orange, and then you realize that even the second fruit is also an orange. But you can also pick the first fruit being a mango, and then again you realize the second fruit is an orange. Or the first fruit could be an apple, and then the second fruit is now an orange. So those are the possible instances. So you're saying this will be the probability that either that the first fruit is an orange, and then the second one is also an orange. Or the first one is a mango, and then the second one is an orange. Or the first one is an apple, and then the second one is now an orange, like that. So here we are not restricted uh, that you observe only one orange, okay? Because there are those instances that you could be asked, what is the probability that you observe one orange? Okay, so one orange will mean that if the first one is an orange, then the second one will be a different type of fruit. Okay, and so in that case, we could not be having this probability here. And therefore, so now you check from your probabilities. So what probability will give you an orange and also an orange? So we had 4 out of 12 multiplied by 3 out of 11, or 3 out of 12 multiplied by, when it is an orange, so that is 4 out of 11, or 5 out of 12 multiplied by getting an orange, which is 4 out of 11. And then now you can simplify that. Okay. Can simplify that. So yes, so we already have an answer. So someone is saying that the answer, so just confirm whether that is actually true. So someone has indicated the answer to be what? 1 out of 3, is it? Right, so yes, so you can go by that. So ensure that you Oh, so 1 out of 3, like they've said. Yeah. And so many questions may arise from this. So, but now remember we talked about, so if you go back to the question up there, we mentioned about without replacement, without replacement. So what happens if it is now with replacement? Okay. So just scroll down there. So I'm writing down after the tree diagram. So if it is with replacement, with the replacement, it means that the moment you pick a fruit from the basket, you return it back. Okay, return it back to the basket, and therefore, so this will mean that every time you pick, so if it is an orange, mango, and then an apple there, then you pick in for the second time. So you can pick as many times. So this is an orange, mango, an orange, mango, an apple. Yeah. So what happens? So we are saying in the first one, the probability will just remain. So 4/12, 3 out of 12, then 5/12, like that. So this is the first pick. Now, once you go to the second one here, since once you pick an orange and it is with the replacement, so it means that you just note down the probability, then you take it back. So therefore, it means that you still have your 4 oranges, and the total number of fruits will not reduce, will still be 12. And your mangoes will still remain to be 3, and then the total will just remain to be 12. So here you find that with the replacement, the probabilities do not change. Yeah, the probabilities do not change. They just remain the same. They remain the same throughout. Even if you pick another instance here, you pick another one, orange, mango, apple. So I'm picking for the third time. So, and every time I pick, I replace or I take it back. So the probabilities will remain like that. But for the first case, okay, I just go to the first instance. So the first tree diagram that we had. So if I wanted to pick a third fruit here, Yeah. Picking the that, so orange, mango, apple. So this means that I've picked first mango, two mangoes. So now I'll be picking the third one. So I'll be the probability. So how many oranges will be left? So I've picked one. So they have been left three. Then I pick another one. So now the probability, since they are remaining now two, it will be two out of, now remember it is without replacement. And so the number of fruits, the total number of fruits that will be remaining will now be 10 there. And then I've not picked any mango so far. Remember it is in the first root here. Orange, orange. Then the mango will be 3 out of, but now total number of fruits are 10. And then the apples will be 5 out of 10. And you can see if you add 2 over 10 plus 3 over 10 plus 5 over 10, then you're supposed to get 10 over 10, which is 1. Okay? And you can do that uh, for any instance there. Okay? So I've just followed this route here. So orange, mango, apple. So if the first one is a mango and the second one is an apple, okay, so to pick an orange, it means that I've not picked any orange so far. Therefore, the number of oranges will be 4, but now the number of fruits will be 10. Then I want to pick a mango, so I picked one mango, and then the second one was an apple. So to pick another one, another mango will now be 2 out of 10. And then I picked a mango and an orange. So the number of oranges remaining will now be 4 out of 10. And you can see again, if I add these probabilities here, they are supposed to give me 10 over 10, which is 1. So you can, the question could be asking you to pick several fruits. So it is upon you to arrange uh, your your tree diagram in order to represent all the possible outcomes. Okay. So is there a question up to that point? Any question? So when you have the terms at least and you have the term at most, okay? So at least means greater than or equals to. Okay, so if we are saying at least 2, so meaning that the least number can only be 2. So it is all the numbers which are equal to 2 or greater than. So the least is 2, so then greater than. But when you use the term at most here, we are simply saying less than or equals to. So if we are saying at most 2, at most 2, it means that the most or the highest value there is 2. So at most 2 will mean uh, values equal to 2 and less than 2. So that is what these terms mean. So at least is greater than or equals to a given value. And then Uh, then at most it's less than or equals to 2. I mean to the value that you're given there. So someone is asking, so why didn't we multiply AO and OA as we have multiplied MO and OM? Why didn't we multiply AO and OA as we have multiplied MO and where did we do that? You remember, I'm not getting your question. Okay. AO, can you unmute? You can unmute and ask so that I can try to understand what is your question about.
Here the second first orange
Mhm.
POO plus P into brackets MO plus PAO.
Mhm.
So we added the MO. We took MO 4 over 12 times 3 over 12, and
Mhm.
then 3 over 12 times 4 over 12. But here we only took AO 5 over 12 times 4 over 11. Are you getting?
5 over 12. Mhm.
Times 4 over 11. We did not add like sasa AOA.
Yes, because the question is asking,
Mm-hmm.
what is the probability that the second fruit, okay?
Uh-huh. Oh, the
The-
second. Yeah.
yeah, the second fruit is an orange, okay? So which
Oh.
means that, so there is a difference if you have been asked what is the probability that one of the fruits, okay?
Mm-hmm.
That one of the fruits is an orange. So if that is the question, that one of
Uh-huh.
the fruits is an orange, then we will consider both aspects that you can have the first one as an
Mm-hmm.
apple, the second one as an orange. And also you can have the first one as an orange, and then the first one, I mean, you can have the first one as an orange, then the second one could be any other fruit. Are you getting?
Yes.
Yes. But now the question was specific that the second one is an orange.
Okay.
Yeah. Then James, when do we start the first pick as half and half? And also, can we have three items while picking them first? Now, we can have, so yes, I think I've gotten your question, James. Now, when we have the first pick as half and half, so like the case of the coin. So let me just write down there where I've explained there are trees and at most. So if you have a coin, okay, so we know that a coin has two sides. A coin has two sides. Therefore, and the sides are a head and a tail. So therefore, to observe any of the sides, then if you draw your tree diagram, you have a head here and you have a tail. So to observe any of them, then it means this is one out of the possible faces, which is two. And then this one would be one out of two. Okay. So this happens when you have when all the possible outcomes have equal chance. So remember we talked about classical approach. So what we are looking for, what we were working on is uh, what we refer to as the frequentist. So you observe how many items are there. And then out of the total items in that basket, so how many oranges? 5 or 4. How many total fruits are there? 12. Okay. Then getting at if the first pick is that, then so I don't know what items has 3 sides. Okay. So we only have those instances only happens when you have equal. Okay. So if we had So if we had 3 oranges, okay, and we had 3 mangoes, and we had 3 apples. Now, in that case, all of them, they are 3, 3, 3. So all of them have equal chance of appearing because it will now be, so orange, mango, apple. So you see that this one will just be 3 out of 9. The other one will also be 3 out of 9. The other one will be 3 out of 9. And if you are simplifying, you can see that this one is simply 1 out of 3. This is also 1 out of 3. 1 out of 3. So that happens only when you have equal chance or equal number of items. Okay. So I hope I've been able to answer that. But when you have several and they are not equal, just like we did the example for the fish. You see, we had, I think, I don't know, 13 blue, 17 red, and maybe 10 of the other types. That is, don't know. Okay. So you add them up. And then for each one of them, so probability of getting a blue will be now the total they are, which is 13, then out of the possible outcomes. They're in the same, just like you see, even for the example we used there, for this fisherman. So he has 13 blue gills, he has 17 red gills, 10, all of them in a basket. So if you want to pick one of them, then it will be how many they are out of the total. Okay. So we cannot say because you have 3 types of fruits that the first pick will be a third. No. It will be how many fruits do you have there of a type orange? So are they 4? Then how many total fruits do you have? Okay, so we cannot have a third because they are in the same basket. No. Forget about the basket. Consider how many items you have in that basket. And you are picking at random. Yeah, we simply say we are picking at random. You just put your hand inside the basket and then you select randomly. You don't know which one. So the moment you select, that is when you observe, oh, it is an orange. And then now you record your probability. So how many oranges are in that basket? And then the total number of fruits. So you're picking randomly. You don't know which one you're picking. Okay, but when you are representing your information in a tree diagram, you just specify orange the way you want. You could even start with apple. Apple in the first branch, mango in the second branch, and so forth. Okay. Any other question? So if you answered the poll, then wanted to share so that I can see whether you can actually recall how many topics are remaining.